Okay, now we make it always the same rectangle for the, or square for the work volume. Go to write 200 millimeters. Okay. I go to work here. I go to work on the plane. No, I don't want to do this. Center radius, center point. And I go to use the trim. I go to delete. No, I want to trim also the arc. Okay, I can delete this. Now I go to select this. Now let me select this one. I go to make a line. From here I select F1, and I go to put 60 degrees. The length can be 50. Yeah. After that I select this. Also here I come from this, I select one, and also here I put 60, and the length is 50. Ora okay, geometry, surface, I select this. No, this is the start, this is this, and we have the surface. Okay. Now I go to select the tool that is flat 20. I lost everything. Why? We make it again. No. Yes. Machine, select the tool, we said flat 20. I come here, 3D surface machine. I select 5 axes and I select the machine surface with the tool side. I select OK. Here we have to write 1, 1 like always. This we say that the rotation 4000. 4000. Stop to be left nothing. 50 millimeters and 20 millimeters of wrapping down tool. This is okay. We come in here. I select this. I want to start from here. And this is it. Our toolpath. Simulation. The machine made this. If we want, here we have also 3D flattened it out. Overlap nothing, we can make it just both or tolerance 0.1. The length must be 20 millimeters, the arc must be the radius 20, the angle must be 45 degrees. I copy also here, auto, everything. This is it is right, okay? Right cut. I select right and right. At least one selected path is after that we make it this, we cannot edit anymore, and we have to put it this. This is it means the machine like this. Okay, I go to make it output and see. Okay, I go to save on the desktop and I call 789. Okay. We come here. We go just on the. If we want, we can do also this. File output cut, save the STL, visible, and I select 7, and I say import on the left desktop 789 STL 8 millimeters. So we have this. The tool, it is already here with the 20. I come here, ISO code, okay, I go to import the file. Input apply, of course, here I have to write. Input apply, 3D animation. Okay, now do you see that the biggest part of the head it is on the bottom? If you remember what we have seen before, here on the operation that we have on the right, we have the three different solutions. Yeah? Like the alternate bottom. But this is, it is an operation made it on the plane. You can see that it is an operation made it on the plane because we have the three letters UPR, using plane rotate, where we have these three numbers plus three numbers. It's not so really important to know what the three numbers means. Okay? But we have the plane. If we go to open this, we have now the three different solutions. This is it, is a real 5-axis operation. You see that for each block we have the X, the Y, the V, the A, and the C. Okay? Of course, just to say to you, you see here we have the 4000, what we have said before, that if we needed to go faster or slow all over, we can change the field. Okay? But we have seen that this is, we don't like. Okay? The limits are okay, but we don't like. If we want to use a different solution, we must write this. UIO, comma, C180. Okay, I go, UIO means using incremental origin. I go to put 180 millimeters, 180 degrees more on the axis. And the machine makes this. You see, it's not correct. If we have to work in correct way, we have also to make a mirror with the mirror of the axis A. I put apply. The machine like this. Okay. Now we have to check the limit. You see that the C go out. We can try to put minus 108. Put apply. And the machine made this. Verify the limit. The limit is okay. Plus or minus depends. You have some operation where you have a lot of rotation that you cannot do that. Okay. Okay, this is for the 5-axis, and to use it the alternate bottom when we have the 5-axis for 5-axis operation. After that, you can see that also here we have not the code that we have learned before, the G41, G42. But if we want, we can write manually and make it the compensation of the tool in 5-axis. Okay. If we come here, we go to write TR, capital letter, TR equal, this is 10, no? The two radius. And after here, we have said that this is a G42. G42. I put apply, nothing happens, because now the tool radius, it is exactly like the tool that we are using. But if we go to modify, like before, remember that is reverse. If we want to stay outside, and this side must be smaller, we try to make put 5. Look the toolpath. When I go to push this, you see that go to modify. Okay. Now I cut less material for 5 millimeters. Okay. Yeah. Yes. Probably it is the only machine in the world that make the 5-axis compensation. Remember this.
Sorry, come again, sir.
This, the Bazi,
Okay.
it is probably the only machine, only constructor that had the possibility to make the 5-axis compensation.
Everything.
Okay? All the others, they say, no, you have to generate another code from alpha to or from any CAD-CAM that you use. Okay, after that, another option that we have, and it is good also if we have operation made it on the plane, it is this. Axis underscore shift equal minus 10 millimeters. I put apply. In the animation, you see that we move it, the cut 10 millimeters down. Okay?
Axis.
Do you see?
Spacing.
Now let me put this is back to 10. I go to right, this is to 0, this is the original. You see, the end of the tool, it is exactly on the end of the surface. If I put like before, this is to minus 10, put apply. Make this go exactly down on the axis of the tool. Remember this, that it is very useful. If not, before on the previous version of Pitagora, everybody used it to make it correctly the depth of this. They're using the length of the tool, but it's not correct. This is good if you have a shaping tool. A shaping tool, and you have to set it exactly. You can do this.
No, it is coming as exactly to 0, sir. Touching exactly.
Yeah, now yes.
On 0 or more it is going. So now here.
I put it 10.
Here 10.
Yeah.
But we have a shifting also. Then why it has not shifted? Minus 10.
Once again.
Can you change this to 0, sir? Or remove it? What is this, sir?
You see that the edge, the edge of this, it is exactly here.
Okay.
If I put minus 10, this will go down on this direction 10 millimeters. If I move it up.
No, because I was confused. Maybe last time it was 5.
Too many times. Yeah, 10. Yeah, I understand. Okay. This is more or less it is what you can do, and also the operator can do when the code is ready.
So there is any like a list for this. For example, you make now your TR the short course, right? So do you have any list here?
Big story. Big story. We see if we have something.
Codes.
Not so much, but something. The three letters, like the UPR, the UEO, and everything, it is real command of the OSI controller.
Okay.
Okay, the OSI controller. You can ask to the service at DANH.
Okay.
If they need to do manuals for the controller, PDF file. But it's too many three letters that you can do a lot of things. Only that in Pitagora later we use it as just the three letters that we really need to work with our machines. And because it is just a letter also for tapping but with our machine we cannot tapping. Or for the late.
Okay.
Something like that, where go to change the field of the destination, something like that.